Hi everyone, welcome to this demonstration about this proof of concept. It's called Agent Omnimesh. What it means is that it's a centralized, unified place for agents to interact in a secure, interoperable, and efficient manner. In today's world, everyone is building agents, and while building an agents in a POC sort of an environment is easy, taking it into production is sufficiently more difficult. It takes time and effort to design an agent. It takes time to test its accuracy, and it also takes time to evaluate whether the agent is being deterministic or not. At the end of the day, to get started with this presentation, I would say that all of these generative AI systems, large language models, agents, all these different tools are inherently non-deterministic. They take in a string input and they what they do is they perform probabilistic distribution to select the next best token. So an LLM inherently is a non-deterministic system. So if you invoke the LLM multiple times, it is not going to give you the same response. You might have seen this with tools such as Claude or ChatGPT. So as you scale this from an LLM to an agent, it becomes more compound. An agent is nothing but an LLM that can call a tool in a loop. A tool is a Python function that performs some sort of an action on behalf of the user. This might be calling an API, making some changes in the database, or performing any sort of interaction, or even communicating with another agent. And this LLM calls this tool in a loop until the user criteria has been satisfied, or there is an error that is encountered, or there is some sort of a recursive limit. And along with this tool, there are several other building blocks that make up what an agent is. An agent today needs to be context aware. It needs to know what the user likes or what the user dislikes. All of that comes from some sort of context, and what this thing is called is memory. An agent also needs to follow responsible AI policies at the input and the output layer. That means the agent needs to be configured with proper guardrails. An agent needs a secure, unified access to tools and permissions on what tools it can access. An agent needs an environment to run in, some sort of compute. Is that EC2, or is that a Lambda function or an API gateway in a serverless fashion, or is it in some sort of a containerized service? All of these different things make up what an agent is, and these things are called primitives. In today's world, building single agents is easy, and now customers and users and organizations are building agents across multiple domains. And guess what? These agents talk to each other, and talking to each other means that there are multiple agents. And the moment there are multiple agents, the complexity of managing these agents, making them more deterministic, managing the flow and communication and context between them in different levels becomes harder. So what I'm going to demonstrate in this solution is an example of an Omnimesh where agents are registered in a single unified gateway where each agent is running on a separate runtime. Each agent has access to its own memory. Each agent is communicating efficiently with the orchestrator agent who is responsible for routing requests to those different subagents in different ways, both deterministically and non-deterministically. Let's take a look at this architecture diagram that you are seeing on the screen. There are a couple of important parts of this solution. The problem statement is that, hey, I am a user of an organization, and an organization has built out several agents for different sort of products or teams. There's a team agent for team one, there's an agent for team two, there's an agent for service one, there's an agent for service two, there's an agent for service three, so on and so forth. And now I, as a user, when I'm coming representing some sort of a team or a service, then my request should go to that assistant, and that assistant should be responsible to have logic to deterministically route my request to any agent within that gateway representing my service. So if I'm a user from service one, then my request should directly go to agent one representing service one behind the gateway without the orchestrator agent or the LLM reasoning, right? So that is one. The second option is if I'm coming in with from no product or no team, then that means that my question should be reasoned through by the orchestrator. The orchestrator should connect to the gateway, should check what are the available agents, should do a semantic search on the number of agents, should retrieve the top relevant agents and make a decision on which agent to call. And if let's say there's no agent, then it should default to a default agent. These are the two different scenarios, right? And there are different levels of complexities to this as well that we will discuss, but there are certain parts to this. First is the orchestrator agent. The orchestrator agent is an agent that is built using a Strands custom graph architecture. So just if you've built an agent on LangGraph, Strands is an easier way to build agents. It's just in a few lines of code where you can build agents both with autonomy and in with determinism. You can create a custom graph within Strands where there are a bunch of nodes and edges within a graph. And those nodes and edges are nothing but Python functions and conditional routers that can do anything under the sun or anything that the code can allow a user to do. It can have some conditional if else logic. The functions or the nodes can have some sort of a routing logic, or the a function or a node within that graph can literally call another multi-agent system. So you get the best of both worlds, determinism and non-determinism, and that is what agentic applications need today. They need some sort of a way to have some determinism within them, and you only get that determinism when you build an agent as a graph where you see the data flowing in from one node and out from the other node and so on and so forth, and you're able to manage the flow between these sort of edges. So coming back to this architecture here, sharing my screen again. So what you're seeing here first is a centralized orchestrator that is built using the Strands custom graph implementation. This orchestrator is built using a custom graph implementation. What it does is that it handles deterministic and non-deterministic workflows. It has guardrails configured. It has context management, memory, configured. It is able to have multi-turn conversations with the users. And this orchestrator, let's say, is running on a separate runtime. It has access to memory. So it keeps in mind what the user preferences are in terms of user preferences are in terms of user semantics, user preferences about their product, or even the past summaries of conversations. It also manages this both at the orchestrator level and also the sub-agent level that we'll get into. Also, there is context-aware routing because of that. So if a user is coming in, the previous context, the previous memory is retrieved semantically from my past conversation histories, the user semantics summaries and preferences, and they are used along with the past conversation turns with the latest user query, and there is context-aware routing that the orchestrator can then do. Another thing I'll mention is that if the orchestrator or if any of the agents are unable to answer a question, then there is also an option to fall back to a default agent, which is also configured within the AgentCore Gateway. There is also cross-agent and MCP collaboration in today's world, and also within this POC, there needs to be some sort of collaboration between agents within the gateway. So let's say if a user from product A comes and asks a question that, hey, what is product 2? Then if that request deterministically routes to product A, then the product A should send a signal back to the orchestrator that, hey, I don't know the response to this question. And then the orchestrator should then decide which other agent to call and calls that agent with that memory. So the agent 2 within the gateway knows that context and is able to orchestrate requests. So there's a shared memory. The agents can collaborate, and you can also have MCP servers within this agent gateway. We also have enabled shared memory using AgentCore Observability. So the orchestrator agent has full awareness of what is going on across all the agents or domain agents within the AgentCore Gateway. And also each agent in itself has idea and has memory of what is coming in from the orchestrator into itself and what is going out of the towards the orchestrator. So there is a global level memory that the orchestrator has, and then there is a unidirectional or memory that only the domain agents have. So there is a shared memory, and then there's memory configured for each agent for context awareness. There is also observability. All of the agents, they emit out metrics in OTel format. So all the metrics are configured within AgentCore observability. Another quick thing is that the orchestrator is configured with guardrails, which means that if the user wants, sharing my screen here again, that which means that if the user wants to have the response from a certain tool emit out directly to the user without being modified by the orchestrator, then that upstream relay is also possible with this architecture. Each agent uses a different LLM, which means that it can also be optimized. So let's get started with the demonstration here. So this is my UI. What you're seeing on the screen is a Streamlit application, and it has a couple of components to it. First, it has the concept of an agent registry. This agent registry contains information about what are the available services within my organization and what are the list of agents that can help with queries about each service. So this is gives us some sort of a visual representation of, hey, what are all the services within my organization? And for questions or users coming in from that service, what are the list of agents, narrow list of agents that can help with that request? So tomorrow, if a user comes in with the query, information from this registry can be used to make a deterministic decision that, hey, a general IT support service has a couple of agents. So let's take a simpler example. Let's take an example of network operations that, hey, network operations is a service. If a user comes in with a network from the network operations group, then their request should deterministically route to the network ops agent instead of the orchestrator making the decision. So there's a deterministic routing. The orchestrator is not making the decision, which means that there's optimized latency cost as well, and the user gets more reliability by interacting with its domain agent from the gateway without the orchestrator coming in between. However, this registry also gives some sort of a good control over what's going on, what are the services, what are the list of agents. So a service desk agent or service will have the service desk agent configured for those type of questions. The cloud administrator would have 4 agents configured to help with those questions. So now a question you would have is that, well, if a user comes from the cloud administrator group, then which sub-agent should help? Because there are 4. Well, then the orchestrator is designed as a graph. You can create your own matching criteria. What I have done is I have said that, hey, if a user comes in from this context, and if there are multiple agents for that context, then select the one with the top similarity score. So it's literally like a semantic similarity score, and the one with the highest score, the agent with the highest score, is the one that is chosen for the deterministic routing. But you could very well do anything within that matching criteria, because at the end of the day, it's all a Python function within a node. I can also add or delete agents from my registry. So this is all I have here. The second thing I have is the gateway. All agents are saved or are configured behind something called an AgentCore Gateway. AgentCore Gateway is a managed interface, a unified interface that hosts agents, MCP servers, or tools in an MCP compatible way. All the agents, in this case, there are 4 agents that I have configured: a service desk agent, which is a default agent, a database agent for database services, a development tool agent for development tool services, an infrastructure agent for infra services. And all of these agents are essentially LangGraph based agents answering their different sort of questions. And they have been running on their own runtimes available as HTTP endpoints. And what we have done is that we have registered them with AgentCore Gateway as OpenAPI specifications. And now the AgentCore Gateway refers to them as MCP compatible tools. So you can think of this pattern as an agent as a tool pattern. So now this gateway has access to 4 agents, and this is what the orchestrator agent will connect to when when a question is asked to it. So there is also a way to just like test these different agents separately as well. So you can think of this like this as like an MCP inspector kind of a thing, where you can test each agent and what each agent does, so on and so forth, right? So that is another thing. So you can see that, hey, I said hi, and it says hello, I'm here with database management operations. What can I help you with? And also, these agents, they give back a signal, and we'll talk about this part. So let's get started. Great. Now let's get started with the demonstration. Let's say that there are several teams or products within an organization, and each team or product has some sort of an agent associated to that. So if we take a look at this diagram, let's say that there are several teams or products within my organization X, and there are several agents that are associated for each of the given product. Now, if I'm a user that comes in from, let's say, representing product A, all of my queries should be deterministically flown directly through that product A agent behind the gateway rather than it being reasoned through by the orchestrator. This design promotes for optimization in latency, cost, as well as accuracy of the agent. So all of the users representing some sort of a product will have their user queries hit directly the product sub agent within the gateway before being reasoned through by the orchestrator. And then we will introduce some other complex concepts such as how do we maintain sticky sessions, when does the orchestrator get involved, so on and so forth. So let's take a look at one of the examples here. So in this case, I'm going to share my screen again. So in this case, I am logged in as a user under the service development tools. And now whatever request that I send as a user from development tools should directly hit the development tools agent behind the gateway. So I'm now logged in as a development tools user. So quickly showing you what the flow would look like. So let's say I'm a user that comes in with some sort of context that, hey, I'm a user of the development tool service. The first thing that would happen is that that request would hit my enterprise IT assistant, which is nothing but a Strands orchestrator graph. And that graph has multiple nodes. One of the nodes has logic to then check that, hey, is this user coming in with some sort of metadata within the request that contains some product context? If let's say that user is from the development tools or any other product, let me make an API call to the agent registry, which is essentially the catalog. And if we take a look at the agent registry, this is the catalog of all of the registered services and the enabled domain agents that can help with the request for that service. So if we take a look at the development tool specialist, the development tools agent is an agent that can help with those requests. So what would happen now in one of the nodes within the graph is that it would check that, hey, in this agent registry, is there any agent that matches the product name context that the user comes in with in their metadata? Which enabled agent has the highest semantic similarity to solve for that request? If there is a development tools agent, then yes, there is a match. So what the enterprise IT assistant will do is that it will skip the orchestrator, which is another node within that graph, and it will directly route the request to that specific matched agent within the gateway, and it would invoke that matched agent. So the flow is that a user comes in with context. If that product context contains the name of an agent which is given within the registry, then it would be a direct match, and that would skip the orchestrator. We would check that, hey, in the agent gateway, we would do a list tools on the MCP, based on the MCP specification, check if there is a development tools agent, and then invoke that. Now, what would happen is that let's say that development tools agent is invoked. What are the different possibilities that that specific agent can respond with? There are a couple of different possibilities. First is that that domain agent, like the development tools agent, knows the answer to the question, so it will answer the user question. What are the other options? That that agent does not know the answer to the question, it's out of scope for that agent, or there is some sort of an error. What should happen then? So all of these things, like these signals, is what the domain agent gives along with its response to the orchestrator system to decide whether that request needs to be directed to the user or the orchestrator for further reasoning. So let's take an example that the domain agent here comes back with a response like the user from the development group says, hey, how are you? And that gets routed to the development tools agent directly. Now the development tools agent will say, hey, I'm doing good. I am an agent for giving you information on development tools. How can I help you? Now, along with that, it would give a signal that, hey, there is more info needed from the user. So now there should be a sticky session that needs to be activated between the user and this agent until the agent deems that, hey, this user is satisfied and I'm done with this interaction. So when the domain agent responds with a message, it would also give a signal. For example, if more info is needed, then it would activate a plugin session and a sticky session that would remain active or true until the domain agent comes back with a signal saying completed. So it would keep following up to the user, maintain that sticky session, and during this sticky session, there at each of the time when the agent is invoked, there is a memory that will be retrieved from the long-term memory for that specific agent only, like the user preferences, semantics, summaries, as well as the past conversation turns. So the agent will always have conversational context, and it will keep responding back with the signal more info needed with its response message until the user says that, hey, thank you for helping me, that is all you can help with, and the agent comes back with a signal complete, and that's the end of the sticky session. So this is the interaction between a user and its direct domain agent from the gateway. No orchestrator agent is being involved. However, now let's say that that agent does not know the response to that question. It is out of scope for that agent. Let's say I'm a user from the development tools product and I'm asking something about, let's say, like a service desk, or let's say it's about some other service. In that case, it would route directly to the domain development tools agent, but unfortunately that domain agent does not have context about the other product, so it will come back with a response saying, hey, this is out of scope, and it would give a signal such as out of scope or error. So what would happen in that case would be that when the orchestrator agent comes back with the out of scope or error signal, this would now not go back to the user, but it would go back to the enterprise IT assistant. And this is where, for the first time, the orchestrator agent gets involved. When the orchestrator agent gets this signal from the domain agent that it's out of scope or error, then it will take this error, it will take the domain agent's reasoning, it will take the user query, it will take the past long-term memory context from this memory store. It will take the past conversation turns and then it will reason that, hey, this was a question that was out of scope or error. Is there any other agent within the gateway based on its API specification and description that can help answer the user question? Or this could be an MCP server or another tool as well. If so, then I will invoke that domain agent and the same stickiness process would follow. And if there is no agent that can help, then I will just resolve to a default fallback agent, which is a service desk default agent that is also within the gateway. So there are multiple flows that are managed here that, hey, if a user comes in with context, if the domain agent knows the answer to the question, there will be a sticky session managed. If the domain agent does not know the answer to the question, then it will give out a signal that will give the orchestrator system a hint that, hey, now I want to reason through and check what are the other agents within the gateway that can answer that question. So all of these flows are managed, and let's actually take a look at that in action. So I'm logged in as a user from the development tools service. And now I'm going to ask a very simple question to show the deterministic flow. I'm going to say, hi, how are you doing today? What can you help me with? This is a greeting sort of a question. And here we just want to show that, hey, if a user comes in from some specific team, even if it's a generic question, based on this product context, this query should directly be routed to an agent behind a gateway for development tools and should skip the orchestrator. So I'll hit send and I'll show some logs, so bear with me, but we'll see some of the things that happens under the hood. So I'm going to hit send, and now there are a bunch of logs, so I'll only highlight what you want to see. So it says, hey, this is the question that I asked, that hi, how are you doing today? And now what would happen is that this would directly, what it would do is it would hit the enterprise IT assistant and then it would do a match that, hey, is there any agent from the development tools product that I can directly route the request to? So let's take a look at that. So it says, okay, let me first build out my orchestrator graph, which is already built now. What I'll do is I'll retrieve the past preferences, semantics, and summaries, and I retrieve that. I extract the user metadata that, hey, the user is coming from the development tools product. is there any tool within the agent registry from the 8 agents that is a development tools agent? I will start doing checks and I'll see that, hey, there is a match found. So then it will make a decision that, hey, there is a best match called development tools. So now what I'll do is that I'm going to skip the orchestrator and I'm going to directly execute that agent behind the gateway. So what I'll do is that I will invoke the gateway URL, which is my AgentCore Gateway, which has multiple agents registered within itself. I will check whether there is a development tools agent behind that gateway, and guess what? There is. And this is another agent running on another runtime. I'm going to invoke that agent with all the previous memories, get the response, flow it through the guardrails, and then provide the response back to the user. So I asked a very simple question. It says, now the development tool agent directly says, hey, I'm doing great. I'm here to help you with development tools, CI/CD pipelines, DevOps, blah, blah, blah. And this agent then from within itself might have access to several APIs or other agents or tools. That doesn't matter. What we want to show here is the reliable orchestration logic that we have built. And then along with this, what I want you to focus on is this. The agent then also gives a signal that, hey, if there is more info needed from the user, this is a signal that is passed back to the orchestrator system to then enable a sticky session. So now that this response type is provided, the next time I ask it a question, the response would not be go through the routing logic and determine which agent to call, but it would directly go to this agent that is now saved within the sticky session logic, and it would invoke that agent with the memory and the previous conversation history. So there would be a sticky session now activated between me as a development tools user and the development tools agent. So now if I asked a more development tools sort of question here, like if I invoke this and ask that question, we will see that in action. So I've asked that, hey, uh, tell me about some things related to development tools. How can they accelerate my productivity? Now we would see how the sticky session is actually activated. So let's take a look at that. So it says, okay, there's a sticky session active that has been found. This was the tool that was used. This is the URL of that gateway. Going to share my screen again. This is the URL of the gateway. This is the original query. This is a filtered query from guardrails. Now that there is an active sticky session that is found, what I'm going to do is I'm going to route the request directly to that tool again with my past memories and invoke that agent. So now the sticky session it found is it invokes the agent directly and it passes it through guardrails and I get a response saying, hey, I'd be happy to help you understand how they increase productivity, so on and so forth. So now it again comes back with a signal saying that, hey, there is more info needed. Because this conversation between me as a user and this agent is still active. So this sticky session will still remain active. So right now the orchestrator has not been involved. That shows that, hey, if I want my deterministic queries to be routed to that product agent, that is what will happen. Now, if I just say that, hey, I am done with this conversation. Thank you for your help. This would be it. Now, this is something that will tell the agent. Now, the sticky session is still activated, so we'll see that. So I've asked it a question. Hey, I'm done with this conversation. So this is actually telling the agent that, hey, I'm done. And this can be anything, right? If your agent is following a specific flow and if a user seems to be satisfied with it, then the signal that should be activated should be sent back to the orchestrator system, should say that, hey, this sticky session has ended. So now it will again, since the sticky session is active, it will route it directly to this agent without the orchestrator engagement. It would invoke it, it would pass it through guardrails, it would use the memory, and then it would come back saying, you're very welcome, I'm glad I could introduce you, so on and so forth. And then it says, it would still say that more info needed, but in some sense it would say completed, and the sticky session would then end, right? So that is sort of an example here. So now if I ask it another question, saying that, hey, like, can you, let's say, you are a user from the development tools agent or the development tools product, and now you're asking about another product, what would happen then? So I would say, hi, and let's actually take a look at different agents here. So if I see that, hey, there's a database agent, so let's say I have a database related query. So let's ask that, hey, can you tell me about the database products? So I'll ask that question. And let's actually see what happens now. So I've asked this question that, hey, can you tell me about database related products? And we will see this in action. Now that I'm asking this, the sticky session is still active, right? The sticky session is still active, but I'm asking about something that is not the role of the development tools agent. So it will come back with a signal saying out of scope or error. So let's actually see that in action as this runs. So let's give it a couple seconds. So now we see that, hey, there's an active session found. The development tools agent is in the works. Let me invoke that with all the memories, right? I'm going to invoke that. And then what that agent does is says that, hey, I specialize in development tools, CI/CD pipelines, DevOps. However, you are asking about database products, so I don't know that. I cannot help you with that. So this question is out of scope. But this thing is not shown back to the user. What happens is that based on this out of scope signal, this request goes back to the orchestrator system, and then the orchestrator agent is invoked. It gives it that, hey, the question was out of scope for the previous agent. Let me take that. Let me take all the memories. Let me take all the past conversation history and let me invoke the agent. So it's actually going to invoke the agent for as a fallback option. It's going to connect to the gateway URL. It's going to list all the tools from that gateway, all the other agents, and the orchestrator then reasons through that, hey, is there a database agent? Yes, there is. I'm going to invoke that and I'm going to get the response back to the user. And I get a response saying, hey, I see that you're interested in learning about database products. Our database agent specializes in so and so. And then I get again a response detailed text because it's a normal response. So now we've seen that, hey, if a user comes in with context, it will be directly routed to that agent, and the orchestrator agent will be invoked for different specific flows. This helps optimize for latency, cost, accuracy, and also supports deterministic and non-deterministic flows. All agents are registered within the gateway. Memory supported, guardrails is also supported. Now, the last flow I want you to focus on is that, hey, if I'm a user and I actually don't come in with any context, and I'm not coming in from any product, then there is no sort of assistance that the orchestrator gets to help make a deterministic decision that, hey, if a user is not coming in from any product, which product should I route it to? That decision is then made through the orchestrator agent. So when a user is not coming with any context, it will route it to the orchestrator agent directly. So if I ask a question like for development tools, and then I also merge a question that I asked about database. So also tell me about databases, right? What it will do is this will directly hit the orchestrator because there's no product context, and then the orchestrator will reason through different agents in the gateway. So I've asked this question, tell me something about development tools, also tell me about databases. I'm going to share my screen again. And what would happen now, and we will see this in action, is, and let's give it a couple seconds here, we'll see the flow, is that there is no product context here, so it will route directly to the orchestrator agent. So it says, hey, there is no product name found, right? There is no product name found in the user metadata. So let's take a look at what happens. So it says, okay, there's no product name found in the user metadata, right? I'm going to retrieve all the past memories. I'm going to pass it through the guardrails. And now there is no user context found. So I'm going to proceed directly to the orchestrator, going to invoke that, connect that to the gateway, list down the tools, and then the orchestrator correctly makes a reasoning and says that, hey, this question needs the development tools agent from the gateway. It needs a database agent. Let me invoke those two. Let me accumulate a response from both of them, and then let me provide that back to the user. And now it gives a really good response from both the agents. This is directly from the orchestrator, and then the signal it gives is text because this is just the orchestrator response. So essentially, what we saw in this demonstration is that this agent Omnimesh contains several product agents behind a single unified agent core gateway, and these can be agents, MCP servers, tools, and these agents can call different agents or APIs. Idea is if a user comes in with some sort of context or some background, then this agent graph supports both deterministic and non-deterministic flows. The heart of this architecture is the orchestrator agent, actually. This orchestrator agent actually is a graph, and there are multiple nodes within a graph, right? So the first node in the graph checks that, hey, is there any user metadata, and let me fetch the information from the registry, right? And if there is an agent, I'll directly route it to it. If there is no product metadata, then I'll route it directly to the orchestrator agent that can connect to the gateway and reason through the tools. Then there is another, there are different conditional routers within this graph that checks that, hey, if the previous response says that there's a deterministic routing, let me just route it to a node that actually invokes the gateway, lists the tools, and then invokes that specific agent, right? There are different nodes. There are about 4 nodes and 2 conditional routers, and all of them persist memory, guardrails, and also they are configured with agent core observability. So do take a look at this, try it out, and let us know if there's any feedback. Thank you.